Okay, guys, we're going to take a look at the tangent ratio here today in the lesson. Very important lesson for you guys getting prepared for trig pre-calculus next year. Off to the side of my screen here, you can see this Texas Instruments multi-view calculator, the same as what we have in the classroom. If you do not have access to a calculator, this is a free download from Texas Instruments. There's instructions in Google Classroom with this lesson on how you can get access to one of these for your computer at home. So we're going to want to also make sure that our calculators here are in degree mode and not radian. Degree right here, you see DEG, that is what you want. If it's not in degree mode, all you'd simply do is hit your mode button. When you go to mode, you've got the options here of degree, slide over to radian. Those are the two kinds of measures that we would use in high school math here. The radian measure is something you'll talk about when you get to trigonometry. So anyway, degree is what you want. After you selected that, hit enter. And when you then leave out of there, you can see here at the top, you are in degree mode, talking about degree measure of an angle. Anyway, moving forward, taking a look at the definition here. Definition says the tangent of an acute angle of a right triangle is the ratio of the length of the opposite leg over the length of the adjacent leg. So important things here. This is a tangent of an acute angle. It's for a right triangle. It is a ratio, and it's a ratio comparing the length of your opposite leg to the length of the adjacent leg. So if I take this definition and I write it in the form of an equation, it would look something like this. It would start out saying the tangent of theta. Well, theta in math represents typically an angle measure. So this is the tangent of some angle measure, happens to be acute angle, and it's equal to the opposite leg over the adjacent leg. So if I take this definition and apply it to this diagram here, ABC, where we say lowercase a, lowercase b, and lowercase c represent the length of the sides. If I ask you, what is the tangent of A equal to? Well, what's the tangent of this acute angle at A? Well, here's the acute angle right here. The tangent is equal to the opposite. Well, what leg is opposite of A? Well, that's this leg over here, which is the length of A. And what leg is adjacent to B? Well, the adjacent leg, or excuse me, what leg's adjacent to A? That would be this side labeled with B. Okay, why would it not be C? Because C is not a leg, it's the hypotenuse. So opposite leg A over adjacent leg B is the tangent of A. Well, if I ask for the tangent of B, if I look at angle B, the opposite side or the opposite leg is B, and the adjacent leg is A, so it would be tangent of B is equal to B over A. Now we're going to take a look at how to use this to find side lengths and how to find angle measures. Now let's take a look at our first example here. It says find the unknown length. So it's asking A is equal to approximately what value? Well, here's A, we're trying to find that. If I'm using my tangent ratio, it's going to look something like this. The definition says that we have the tangent of an acute angle of a right triangle. Well, the acute angle that we're going to look at that we have labeled is this 25-degree angle. So it's the tangent of this 25-degree angle. And that is equal to the opposite. Well, the opposite leg is A over the adjacent leg. Well, what's adjacent to this 25-degree angle? Well, that's that length of 5. Well, I've got an equation set up here, and this looks a little strange to us potentially because we don't typically work with the tangent of 25. But don't fear, the tangent of 25, guys, that is just a number. And I can plug it into my calculator here. We'll show you what that is. If I type in tangent of 25 and hit enter, it's this long never-ending decimal here. So basically the tangent of 25 is just some decimal number. So as I go to solve this equation, I'm going to put it over 1 so I have a proportion. And we've learned that to solve a proportion, I can take the product of the means, which is a times 1, which in this case is a. And that's equal to 5 times the tangent of 25. So really what I have to find a is I'm taking 5 times this decimal number that we found earlier, and this is basically just a calculator activity to find your answer. So all you have to plug into the calculator is exactly that. You're going to type 5 times the tangent of 25, and then we hit enter, and our answer is going to end up being 2.33, and it goes on and on and on, and I'm going to stop after 2 decimal places. So the answer is approximately 2.33. So why do I put the squiggly equal sign there? Because this is not an exact value. This is a rounded off answer. So it's approximately equal to 2.3. Now, when you're working through these, when it comes test time, I am going to ask you for 3 things. 1, I will want the equation. That is this step here. 2, I will ask you what you have plugged into your calculator, which is this step here. And 3, I'm going to want you to show me your answer. So for each of these, I need to see all 3 of those steps. Let's take a look here at our next example. In the next example, we've got this triangle. It's asking me to find the length of A again. And to do that, I've got this acute angle at 65 labeled. So I'm going to say, using my tangent ratio, I've got the tangent of 65, and that is equal to the opposite. Well, opposite of 65 is 5, over the adjacent leg. Well, adjacent to 65 is this length of A. Well, remember, just the tangent of 65, I could plug that in the calculator. That's just going to be some decimal number. And I can take that number and I can always divide by 1. So I'm going to do that, and this sets up a proportion again to solve. So in this case, when I take the product of the means and extremes and set them equal, I've got A times the tangent of 65, and that is equal to 5 times 1, which ends up being equal to 5. Now, this looks a little bit goofy to us. We're trying to solve this equation to find A, because that's what the question's asking. And really all this is A times the tangent of 65. Or remember, tangent of 65 is just a number. So in order to get A by itself, the opposite of multiplying by the tangent of 65 is going to be to divide by our tangent of 65. So I divide each side by the tangent of 65. And as I do that, that is going to give me my answer, or my length of A. So when I look at this, the tangent of 65's cancel. All that's left over here is A, and that equals, well, let's go to our calculator to figure out what it equals. I plug that in. I'm going to clear off what I had there before. I'm going to take 5, divide the tangent of 65, and when I do that, it equals the exact same number that I just had on the last problem. Why did we get the same answer? Well, here's why we got the same answer. Because I gave you the exact same triangle twice. I should get the same answer. If I looked at this triangle here, if this is 65, wouldn't this acute angle here have to be 6, or if that's 25, wouldn't this acute angle here have to be 65? Certainly. So really, this is the same triangle twice. I just found that exact same side length of A 2 different ways. The other reason I did this is I wanted to show you, all right, in this case, the unknown value you were finding was in the numerator of my ratio. Here, the unknown value is in the denominator. So if I'm asking you to find a side length, one of those 2 things are going to happen every single time. So now you've got an example of what happens when the unknown's in the numerator and what you do to solve when the unknown's in the denominator. And once again here, I need to see your equation right here, which is what you're plugging into the calculator. And here, I need to see your answer. So I need to see all three things each time. On to our next. It says find the unknown angle measure. Well, to find an unknown angle measure, it's asking me to find the measure here of this angle at A. Well, A is an acute angle of a right triangle. So I should be able to set this up with the tangent of A, my acute angle that I don't know, is equal to the opposite side of 5 over the adjacent leg of 8. So it's equal to 5 over 8. Now, this is a little different. This isn't the tangent times A. This is the tangent of this acute angle A. And so to get A by itself, you might be thinking, well, what do I do to get A by itself? Because what's the opposite of the tangent? Well, the opposite of the tangent is what's called the tangent inverse. So to get rid of the tan over here, I simply move it to the other side and we write it as the tan inverse. And I need the tan inverse of this 5/8. So, all right, so I'm going to go into my calculator and I'm going to plug in the tan inverse. And you say, well, how do I get the tan inverse? Well, that's simply the second function key and then the tangent button. Okay, so now it says tan inverse of 5 divided by 8. I'm going to close the parenthesis and I'm going to hit enter. And when I'm done, I've got an answer of 32, or at least approximately 32 degrees. So rounded off, the measure of A is 32 degrees. All right, let's take a look at one last example here. I've now asked to find the measure of angle B. Well, the measure of angle B, I can set up my tangent ratio again. So this is going to be the tangent of angle B, my acute angle. That is equal to the opposite of 10 over the adjacent leg, which is 8. And so I'm asked to find an angle measure just like we did up above. Remember, this is not multiplication. The opposite of the tan, to move it to the other side, we've got to do what's called the tan inverse. When I do the tan inverse, that gets rid of the tangent on this side and moves it over here. All right, so I do my tan inverse, or basically my opposite operation, and I do the tan inverse of what's over here, which is 10 over 8. And when I plug that in the calculator, that's going to give me my value of B. So let's take a look. I do second tangent. So second tan gives you the tan inverse of 10/8. So 10, and you could do your fraction. Last time I did the division. So 10 over 8, and I arrow out of my fraction and I put my parenthesis. So the tan inverse of 10/8, I hit enter, and I end up with an answer here of 51.34 degrees. So I'm just going to make this 51.3 degrees. Now, just like I said on the previous problems, I need to see all your steps. I need to see what you are writing for your equation. I need to see what you're putting into the calculator, and I also need to see then your final answer in the end. So I need 1, the equation, 2, this is what goes in the calculator, and 3, your answer in the end. So the big dilemma in this section for a lot of people is, well, when do I use the tangent key and when do I use the tan inverse? Well, it's rather quite simple. If I'm asking you to find an angle measure, okay, in order to solve this equation, you are using the tan inverse. So to find an angle measure, you are always going to do the tan inverse on your calculator. Go back a slide. Whenever I ask you to find the length of a side, an unknown length, you are not using the tan inverse. You're using just the regular tangent key, and that will be consistent all the time. So what do you do on the calculator? To find an angle measure, you use the inverse. To find a side length, you use just a regular tangent key. On to our last example here. We're going to talk about slope and how it relates to the tangent. Well, the tangent of theta, we already know from our definition, is the opposite over the adjacent. Well, right now we're going to talk about it also equals slope. The tangent of theta is equal to rise over run. I'm going to explain why that's the case. We're going to take a look at this example to do that. So find the measure of the acute angle that the line makes with the horizontal. So here's my line, y equals 1/3 x minus 2, very familiar slope-intercept form. And as I would go to graph this, I would simply go to -2 on my coordinate plane, and then I'd rise 1 and run 3. So there's the graph. Then the question is, find the measure that of the acute angle that this line makes with the horizontal. So to take a look at that, we need to draw in this horizontal line, which I just did. So when I draw in this horizontal line, the question they're asking, guys, is this. What is this angle here, the acute angle that this line makes with a horizontal? Well, to go even a step further, I'm going to go ahead in this diagram and draw in this little vertical line right here. So now I have a right triangle. And if I'm asking for this angle measure, I could set up, and you guys would be very comfortable with this from what we talked about in the last examples, that the tangent of my acute angle, which is right here, I don't know what it is, so let's call it our Greek letter theta. So the tangent of theta is equal to, we know from before, the opposite. Well, if I'm using my grid, the opposite length is 1 unit length long. Okay, over the adjacent leg, well, this adjacent leg is 3 units long. So the opposite over the adjacent is 1/3. But hold the presses. What was 1? 1's not only the opposite, but 1 represents the rise. And what's the 3? Well, it's the adjacent for the triangle, but for my line, it was the run. So the rise over the run is the exact same thing as the opposite leg over the adjacent leg. So I would go ahead and solve this. I'm finding an angle measure. So I say to myself, self, what do? I'm finding an angle. Oh, yes. Whenever you find an angle to solve, you're going to use the tan inverse. So it's going to be the tan inverse to move the tangent to the other side of 1/3. So here we go, tan inverse. Second tangent key, and I do the tan inverse of 1/3. So we plug that in, close our parenthesis. Maybe not. Got to get out of that fraction first, close our parentheses, and then we hit enter. So theta ends up equaling 18.4 degrees. So anytime I ask a question like this to find the measure that the acute angle makes with the horizontal, that the line, all you have to do is simply take the tangent of theta, or whatever you want to call your angle, and set it equal to slope. You don't have to draw the whole diagram. I just did that to show you why the tangent of theta, which means opposite over adjacent, but also in this case means the same thing as rise over run. So as far as the lesson goes, guys, that's it. A quick recap. Remember, you use the tangent key when you are finding a side length. You're using tan inverse on the calculator when you are finding an angle measure. Go ahead and see me in the chat room if you have questions. I hope you do well with this. And this is, guys, as I said, a very important lesson. So make sure that you take the time to possibly even watch the examples in the video again if you don't understand. Anyway, have a great day, and we'll see you online.